Let's analyze motion graphs for free fall. So we are going to look at three types of graphs. One is the position time graph, one is a speed time graph, and one is the velocity time graph. We are going to consider upward direction as positive and downward as negative, and we will use it for any vector quantity like velocity in our case. So for that we will look at an example of free fall. So here we have a ball which is at position A, that is a starting position, and we say that position at A is equal to 0. It is going to be thrown upwards, so we have to have a velocity for it or a speed for it, which is 5 meters per second. That is the initial speed or velocity of the ball. We can see that in the position time graph we have labeled A, which is at the origin, which is the starting point of the object. Now for speed time graph, because it's starting with an initial velocity or speed of 5 meters per second, we start the graph from 5 on the speed axis as well as on the velocity axis. As the object moves forward, its velocity or speed is going to decrease. Let's take another point B. We can see that now it is at a different position, so it is far from its original position, and we are going to say that the velocity at this point be 4 meters per second. So for the position time graph, we have got this point B on the graph. At some time t, its position has increased, and now we have got point B on the graph for xt. Similarly, we will have point B plotted for speed time and velocity time graph. For speed time and velocity time graph, we are going to have B positioned at 4 meters per second. That means the value of speed at point B is 4 meters per second. As it goes ahead, the velocity or the speed further decreases and it reaches to 0. Because the speed at this point is equal to 0, we can see that we have plotted point C on the x-axis. That means showing that the speed at this point is equal to 0. Similarly, for velocity also, we can see that the velocity will also be 0, so it is plotted on the x-axis. For the position time graph, we can see that it has reached the maximum position, and that's point C plotted on xt graph. After this point, the ball is going to turn and its direction is going to change, and it's going to return to its original position. So we are going to have point D, and this point D, we can see that now the ball is trying to return back to its original position. So in the position time graph, point D is close to the x-axis. That means now the object is going to return back. Let's say that the speed at this point is 4 meters per second. So we will draw the speed at point D, which is at 4 meters per second. And the velocity will be negative 4 meters per second because it's a vector quantity. So that's a very important difference in the speed time graph and velocity time graph. The speed remains 4 meters per second, whereas velocity is negative 4 meters per second because of its direction, which is downwards. Then the object returns back to the original position, so x is equal to 0, and the velocity or the speed which it will have will be the same as it was having when it was thrown upwards, which is 5 meters per second. So let's name that position as E, which will be same as A. So on the graph we can see that position time graph, E is on the time axis. Okay, and we can complete the graph. We can see that it's a curved graph. For speed time graph, we have got E at a value of 5 meters per second, and we can see for the upward journey, the graph is a straight line, okay, with a negative slope. And for the downward journey, we have an upward slope as it is accelerating. For velocity time graph, for the upward journey, we can see that it is having a negative slope. for the upward journey, and point E can be plotted at negative 5 meter per second, negative because it's downward journey. We can complete the graph and we can see that the slope remains the same. So for the downward part, we can see that the slope is negative as well as velocity is negative. That means as the object is moving downwards, it's going to accelerate because slope as well as the velocity is negative. For the upward part of the graph, we can see that the slope is negative and velocity is positive. That means it's decelerating. So that's how we complete the motion graphs for free fall.